In lesson 2, we're going to continue with our transformations and we're going to look at dilatations. So a dilatation is something that is either going to stretch or compress a graph. And we can either stretch it vertically or horizontally. So we're going to start with, again, you're going to use this on Desmos because it's easier to see what happens, or you can make a table of values. So we're going to start with y equals x squared. So here's my basic 1, 2, 3. Here's my original graph, y equals x squared. And we're going to see what happens when we multiply x squared by 1/2. So if I type this into Desmos, what's going to happen is so we're squaring first. Keep this in mind, we're squaring x first and then we're multiplying by 1/2. So what's going to happen is the graph is going to be half as high. So 1/2 x squared. So when I square 1, I get 1, but then I'm multiplying it by 1/2. So it's only 1/2 as high as the original function. So the vertex is 0, 0. So you'll notice that when I multiply by 1/2, the vertex does not change. The vertex is still at 0, 0, but it's going to vertically compress by 1/2. And compress means I'm squishing it down. So it's not as tall as x squared, it's compressed by 1/2. It's kind of like having a balloon and sitting on it or pushing on it, it squishes it down. Then I'm going to do 1/3 x. So what's going to happen is 1/3 is going to be only 1/3 as high. I'm actually going to fix this a little bit so I have some room here. So let's do the 1/2 again. Make this a bit bigger. So 1/2 is about here. So there's 1/2, and then I want to do 1/3. So now when I square 1, I get 1, but now I'm multiplying by 1/3. So that's not quite as high, a little bit more compressed. So 1/3 would also be compressed by 1/3. So the vertex is still 0, 0, because when I square x and I square 0, I get 0. So when I multiply 0 by 1/2 or 1/3, I still get 0. So the vertex does not change, but I can see that it is vertically compressed, this time by 1/3. So it's 1/3 as tall as the first one. And then the last one is 1/5. So now it's going to be over 1 up 1/5. So that's going to be less tall. So it's hard to see on here, but if you do it on Desmos, you'll see the dilatation. So now the vertex is still 0, 0, but this one's going to be vertically compressed by 1/5. So by multiplying the x squared by a fraction, you are going to compress it. You are going to squish it down. Right? So vertically, if we're just talking about vertically, it's going to be a compression. Okay, so we're not talking about, because a vertical compression also looks like I've pulled it wider. So it's important to know that you're squaring the x first and then you're multiplying. So that's going to be considered a vertical dilatation because you are changing the y. So x doesn't change. You're squaring x. And then you're multiplying by a number which is going to change the y coordinate. So we say vertically compressed by 1/2. And then this one is vertically compressed by 1/3. So in summary, we can say that if we multiply x squared by a value of a, where a is a fraction between 0 and 1, the parabola is going to be compressed by a factor of 1 over a. Or maybe we'll just say a. Okay, let's look at if we multiply by a number that's bigger than 1. So again, we're going to do 0, 0 for our original function. So here's x squared. Then we're going to multiply by 2. So we're squaring first. So 1 squared, let's say we use, let's say we start x is 0. 0 squared is 0 times 2 is 0. 1 squared is 1 times 2 is 2. So here's my new point. So here's my new point of 2x squared. So you can see that the vertex did not change, but it is now vertically stretched. So it's like pulling it up. Right? So now it's double in height. So you're pulling it up, you're vertically stretching it up. And the reason it's vertical is because you're not changing x, you're keeping your x values and squaring them first, and then you're multiplying by 2 after. If I square 1 and then multiply it by 5, I get 5. So 1, 2, 3, 4, 5. So now the points are up here. So if I do a vertical stretch of 5, it pulls it up. So the vertex is still 0, 0, but now it is vertically stretched by 5. So it's pulled up even higher. And then finally, if I do 7, my points are going to be way up here. So it's going to be vertically stretched even more. Vertex remains at 0, 0, but it will be vertically stretched by 7. So it's 7 times as high as the other one. So it's like pulling it up. So a compression is like squishing it down, and a stretch is like pulling it up. So my conclusion would be, if I multiply by a and a is a positive number, the parabola will be stretched by a factor of a. And then finally, maybe we'll add a negative here. So maybe a is less than 0. So I'm going to do negative 2x, negative 5x, and negative 7x. So we'll start with x squared. So vertex is at 0, 0. Now I'm going to multiply by negative 2. So 0 squared is 0 times negative 2 is 0. 1 squared is 1 times negative 2 is now negative 2. So that is going to not only stretch it, but also flip it over. So the vertex is still at 0, 0. It has a vertical stretch, so it is making it skinnier, pulling it up, and a reflection. So the reflection is in the x-axis. This x-axis is the mirror line. So we're flipping it over this x-axis. If I do negative 5x, it's not only going to stretch it by 5, 1, 2, 3, 4, 5, but it's going to flip it over. So it's going to make it skinnier, pulling it down, and flipping it over. So the vertex still stays at 0, 0. It's going to have that vertical stretch of 5, and it's reflecting it. And then finally, negative 7, it's going to come way down here. 1, 2, 3, 4, 5, 6, 7. And that will have a vertex of 0, 0. And it will have a vertical stretch. Oops, spelled that wrong. A vertical stretch by 7 and a reflection. So it's important to note that the reflection is in the x-axis. It flips it over the x-axis. So if I have a less than 0, the parabola, I've got that in twice there. The parabola is a reflection across the x-axis. So that's the main part, the negative. So if you multiply by a negative, it's going to be a reflection across the x-axis.